In this video, we are going to learn about how to create a schematic symbol and PCB footprint for 7805 SMD IC. In previous tutorials, we have learned how to create a schematic symbol and PCB footprint for through-hole technology of 7805 IC. But now we are going to focus on SMD version of the same IC and create a different package for that. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. This video is divided into 4 important parts. First one is understanding how the datasheet of the 7805 SMD version IC looks like. Pretty much it looks same and very similar to the 7805 with a regular version. Why? Because when it goes to the SMD version, the current rating decreases by half, which is all about 500 milliampere. So we are going to explore about the different packages available in datasheet to understand which component library to be designed. Second step is creating a schematic symbol using EasyEDA. This schematic symbol is exactly same as the previous tutorial when we have designed the 7805 schematic symbol in our second tutorial. Third step is to creating a PCB footprint using IPC standards and Cartesian geometry with the different package that we have selected as a SMD IC of 7805. Last but not the least, fourth step is to combining a schematic symbol and PCB footprint to create a component library so that whenever we want to use it in any project, we can use it as a component library. Here we have a datasheet from ST Microelectronics, which is a leading company in microcontrollers, which is very popular in industrial automation called STM32. So this particular company is having a datasheet or a manufactured part number of 78 series regulators, linear voltage regulators. So that's why we have this particular datasheet in front of us. This particular IC, which is 7805, is also comes with a different voltage package, which is all about 7806, 7808 and 7809 and so on. But current rating, a maximum current rating for this particular IC is 0.5 ampere, which is 500 milliampere because it is in SMD version. When it is in through-hole version, when it is having the ability to dissipate heat through heat sink, then it is okay to handle a higher current. But when it goes to the very compact version or when it goes to the SMD version, it becomes unnecessary to create a component with a higher current when it is not used more popularly in industry. Because whenever we need a higher current, we go for DC-DC buck converters or buck boost converters or different types of converters for a higher current and a constant voltage. Considering that, in this data sheet, you can see that this particular IC is having a different information and different packages available. TO220 package is also available with a 0.5 ampere. Of course, a cost is going to be a little lesser than the 1 ampere version one, but nobody uses it for 0.5 ampere with a TO220 package. But what we are focusing or what we are interested in this tutorial is all about DPAK, which is all about SMD version of 78M05. And if you scroll a little bit, you can see the internal diagram and all the details about this IC, a typical application circuit and everything, which I'm not going to dive deep into that. The most important information what we want right now is all about ordering information. In that, I have selected L78M05 ABDT-TR. The specific part number is necessary to search the supplier information. That's why I have selected. Based on your requirement, based on the datasheet information, you have to select a specific part number as per the project you are handling. And when it comes to dealing with the package or dealing with the footprint design, we can see that DPAK or a TO252 package information is given here. It is difficult to read this datasheet. Why? Because they have given the entire dimension table in one page and the dimension details in another page. So going backward, coming backward is little complicated at this point of time for the tutorial purpose. That's why I have written those dimensions in front of that letter. For example, height of the IC from one edge to another edge is 9.5 mm. So whichever is information is essential for us to design a footprint, I have noted down all that information in this particular image only so that we can refer it quickly and start designing the component library. Considering these information from the data sheet, it is time to go for EasyEDA to create a schematic symbol. So let's get started with that. Here we have a EasyEDA, and I'll go to the file and create a new schematic symbol. The symbol design for 7805 is absolutely same as the previous one which we have designed. So I'm not going to explain too much of that. Let's get started with that. Alright, now you can see that the schematic symbol design is complete. I have tried different options in this EasyEDA so that you can explore different opportunities and options in the tool actually. Just give a try with the different options and different settings with respect to naming of the pin number, or maybe with adjusting the height of the IC design and all. With respect to some ICs which has option to change the dimension, you can give such tries with respect to creative design activity. However, it is going to be the same one, like 3 pins. First pin is a V-in, third pin is output, and second pin is going to be ground. You cannot change the numbers and associated pin name for that, but you can change the aesthetic look of the entire schematic symbol as per your convenience. Once we are done with that, I have referred the Moser Electronics again as a reference for supplier part number. Based on your project, based on your supplier, you can refer their website and get the detail about the supplier part number and supplier name. So I have filled all that information and given a prefix as U ? Because it is integrated circuit. Once we are done with this, it's time to go for the PCB footprint design with a DPAK package. So let's get started with that. For creating a PCB footprint, I'll go to the file and create a new footprint. Here what we need to do is we need to create a 3 pad. One is going to be, of course, we have to have SMD pads. So I'll click on the first pad and change it to the top layer and make it as a rectangular one. Dimension wise, we'll change it later on, but I'll place a 3 pad just like this. Second pin is going to be the ground one, first pin is input, and the third pin is output, just to make sure that it is correct. So first, third, and second pin here. And when it comes to schematic symbol, first pin is input, second pin is ground, and third pin is output. Even in datasheet, if you go here and see the pin configuration, second pin at our position of design is going to be ground, first is going to be input, and the third one is going to be the output. We can change the pin number, just make sure that wherever you are placing that pad in the PCB footprint matches with the datasheet information. So I'll just make sure that the first pin is here, third is here, and second one here. So let's get started with the Cartesian geometry and dimensions as per the datasheet. Alright, now you can see that we have completed creating a PCB footprint with a DPAK or maybe TO252 package as mentioned in the datasheet. Dimensions are pretty complex with respect to DPAK IC. It is okay to have a little bit verification with respect to the datasheet information and the regular IC or a physical IC if you have one in your store. Just make sure that all the dimensions matches properly. Otherwise, it becomes difficult to adjust the component at the time of soldering activity, because in through hole component we can bend the lead and make sure that they matches with the soldering process. But in SMD version, we cannot bend the lead however we want it. So just make sure that you are matching with the dimensions at the time of designing SMD packages. But also make sure that you have a pin number correct, because if you have a pin number wrong, then you cannot change it when you are done with designing a PCB and fabricating them. So in this case, I have completely done with the schematic symbol and PCB footprint, and I have verified all the pin number properly. Now it is time to go for the fourth step, that is all about combining this footprint with a schematic symbol. For combining a schematic symbol and a PCB footprint, I'll go to the schematic symbol that I have designed recently and I'll click on the footprint option. Here I will search for the package that I have designed, which is all about TO252 package. And I'll click on the particular information visible to me. Make sure that it is in workspace only, because if you search in global library, then you will get the packages designed by everyone else. So you just need to make sure that you are in workspace to confirm you are in same place where you have designed your packages. Then once we can see that all the pins are properly aligned, we can click on update footprint. Then we are done with creating a component library for 78M05, which is SMD version of 7805 regulator IC. Super duper! I believe you have enjoyed and understood the entire process of creating a SMD package, PCB footprint, as well as creating a component library with a DPAK IC package. If you have any questions or any suggestions or any comments, feel free to comment down below to this particular video. Thank you so much for watching this tutorial. See you again in the next one. Until then, tune yourself to make a difference.